All right, Chem students, today we're going to start our unit on solutions. You'll need your notes packet and something to write with. Okay, this unit contains many new vocabulary words. You're going to need to know the definition for each of these. No, you don't have to make a foldable, but flashcards or something would probably be helpful. Okay, the first thing I want to emphasize is that solutions do not always have to be a solid dissolved in a liquid. We can have a gas dissolved in another gas. An example of this is air. We're always going to have a solute, which is the thing being dissolved, and a solvent, which is the thing doing the dissolving. So for air, when we have a gas in a gas, our solute, we're going to be oxygen and the other gases in air, and it's dissolved in nitrogen because that's the highest percent composition of the air. Now, a gas in a liquid, a great example is a carbonated beverage. The solute this time will be the carbon dioxide, and it will be dissolved by the water. A liquid in a liquid, vinegar will be the to make vinegar, we will take acetic acid as our solute, and we will dissolve it in water. And the last one is just a solid in a liquid. That's the one you're most used to seeing. The solute will be the sodium chloride or the salt, and it will be dissolved in water again. Now, this is also why, if you remember from our last unit, we call water the universal solvent. It can pretty much dissolve most things. Now, we need to talk about the differences between solutions, colloids, and suspensions. First thing we want to do is talk about the particle type. For a solution, the particle type is an ion or a molecule. It is very, very small. For a colloid, it has smaller particles, but not quite as small as ions or molecules. And in suspensions, we have very large particles. So again, solutions have the smallest particle type. Colloids have a medium particle type, and suspensions have the largest. Now the next one is the effect of light, called the Tyndall effect. And basically we're asking ourselves, will it reflect or scatter light in different directions? Now a solution does not scatter light. Light will pass right through it unaltered. A colloid, light does get scattered, so it cannot pass straight through a colloid, and a suspension also will scatter the light. Now the next one, does gravity have an effect on it? Solutions, no. Like the particles will not be affected by gravity in any way. Neither will a colloid. However, a suspension has very large particles. Those particles will settle all the way to the bottom. Now, filtration. Can we filter out the particles? For a solution, no, we cannot. For a colloid, no, we cannot. But a suspension, yes, we can. Just like the large particles that settle at the bottom, we can also pass them through a filter and trap them, and therefore remove them from the solvent. In uniformity, this is our last one. Now, uniformity, this means, is it the exact same throughout? Now, a solution, yes, it is. The composition at the top is the same as the composition of the bottom or any other sample you take from anywhere in that sample. A colloid also is going to be the same. A suspension, however, no, it won't. There will be differences, particularly the large particles that could be on the bottom. That means there might not be anything up at the top. Now, examples of each of these to help you remember: a saline solution, Sprite and vinegar, Gatorade, these are all solutions. The very, very small particle size, either ions or molecules, they do not scatter light, meaning light will pass straight through it. Gravity has no effect. Filtration has no effect, and they're uniform throughout. Now, a colloid. Colloids also have small particles. They are medium in size. Colloids do have Tyndall effect. It will scatter the light, and gravity does not have effect. They also are not affected by filtration. It will not filter any particles out, and they are uniform throughout. Examples of colloids are milk, mayonnaise, whipped cream, and gelatin. They are slightly thicker than our solutions. Our last one, suspensions. Good examples are muddy water, calamine lotion, paint. They have very large particles. Yes, they will scatter light. Light does not pass through them unaltered, and in some cases, light can't pass through at all. Effective gravity. Gravity will separate them into layers. The heavier particles will sink to the bottom. They can be filtered because of those large particles, and they are also not uniform either. Okay, that concludes today's lesson. So go ahead and do the corresponding practice packet pages, and we'll see you for the next video.